I hope everyone's having a great day. Thank you for joining today's Rev Virtual session featuring Harvinder Atwal of Money Supermarket. The topic of today's talk is DataOps, the secret weapon for delivering AI, data science, and business intelligence value at speed. During today's session, if you have any questions for Harvinder, you can go ahead and submit them in the Q&A window you should see at the bottom of your screen there, and we will address as many of them as we can toward the end of the session. And we will follow up today's session with a recording. And over to you, Harvinder.
Well, hi everyone. Glad you could all make this talk. A bit about me. So I head up the group data function at Money Supermarket. What's different for us is that group data is really integral to the organization, and we're actually organized in a slightly different way from a lot of other data functions which might be split out across the entire organization in many other companies. But for Money Supermarket being so critical, I kind of own the entire end-to-end data lifecycle and supply chain, if you like. So that encompasses the data engineers, data architects, DBAs, data scientists, product analytics, and data science, and so on. So there's a lot of learning which I can hopefully share from having that responsibility with you today. But I've actually been working in analytics for quite a long time. Well, actually my entire career I've been working with data and algorithms. Actually started off back a long time ago with operational research, which I guess was kind of the data science of its day. Did various roles in operational research. And have also worked with sort of large-scale data sets at Lloyds Banking Group and Dunnhumby, who are famous for running Tesco's club cards. So Dunnhumby were one of the very first organizations to harness the power of data and use that to drive loyalty and benefit for both customers and an organization. So most of you, I'm guessing, probably aren't familiar with Money Supermarket. We're actually a group of companies. We're a price comparison website. So we have our main brand, which is Money Supermarket. Money Supermarket allows you to compare prices on a lot of different products. So anything from motor insurance through travel insurance, credit cards, loans, your home energy provider, broadband, and so on. We have Travel Supermarket, which is, as you can probably guess, a price comparison website for travel products, flights, package holidays, car hire, hotels. Unfortunately, not doing too great at the moment because not many people are traveling. We have Money Saving Expert as part of the group. That's the UK's largest consumer affairs website, so it's quite famous. And recently we acquired a B2B business, Decision Tech, which actually powers some of our competitors. One of the great things about Money Supermarket is our vision and mission. So we're there to help people save money, and data is a really major part of that. We actually have quite large scale. So we estimate that over the course of the year, around 80% of the adults in the UK who are online will visit one of our websites, which actually gives us more visitors actually than Facebook in the UK. So we use data in many different ways, but really you can kind of bucket up the uses of data into product creation, customer experience, business efficiency. Actually, there's a fourth, which is sort of monetized data publishing or data products. We do that as well. So in product creation, we'll be helping our product teams with experimentation, understanding how certain features and products are doing and how we can optimize them. Customer experience, we use data for personalization, so make sure that our communication and what we show customers is as relevant as possible. And then there's business efficiency, so a lot of that is actually ensuring that we're using data to drive marketing effectiveness, because that's actually our biggest cost. So applications for using data aren't in short supply. I mean, there's many examples of how you can use data: predictive maintenance, anomaly detection, pricing, translation. I'm sure many of you are using data to drive value through many applications. So you think we're living in a world where data is making a massive difference and making the world a better place. But actually, when you actually dive deeper and look at what the data is saying about data itself, it's actually showing something quite worrying. It's actually saying that there's a big problem. And here's some examples. So New Vantage Partners, they run a big survey every year of executives. And they found in their latest one that only 7.3% of organizations say the state of their data and analytics is excellent. And that's not just an isolated survey. There are many others which give a similar story. So this one from, I can't honestly remember where I got this from, whether it's Gartner, Forrester, or one of the others. But they say that 22% of companies are, only 22% of companies are seeing a significant return for all that investment they make in data science. And then if you look bottom up, ask the data scientists, they also have major issues. So Kaggle do the state of data science and machine learning survey. And data scientists are saying that they're struggling with dirty data, talent, lack of support from management, they can't access the data and so on. And so you think with all these problems, people will be talking about them, trying to solve them. But actually when you go to conferences and talks, they're often discussing completely different things. So I did a sort of word count of the synopsis at London Strata, and top things people were talking about were actually technology, so Spark, Kafka. So let's just contrast that with problems data scientists have, dirty data, difficult to access data, and people are actually talking about Spark, Kafka, Hadoop. So there's a real disconnect there. And the truth is that technology is actually far less important than you think, and that's again because the data says so. So those of you who don't know, Jess Humble and Gene Kim are founders of the DevOps movement, and they ran a massive survey again of lots of organizations, and they found that there's actually no correlation between system type and performance. So what they were expecting was that companies with greenfield cloud technologies would outperform those that were running on legacy platforms. And actually that wasn't the case. They just couldn't find that correlation. And in case you think I'm cherry picking, here's that New Vantage Partners survey again. And they're actually finding that fewer and fewer people are saying that technology is a barrier to becoming data driven. So actually, not only is technology keeping up, it's actually running ahead of actually people and processes. So it's very unlikely to be a barrier to be causing some of these issues that we're seeing with not being able to create value from data. So the obsession with technology is not the only obsession out there. The other obsession out there is with algorithms themselves. And in data science, especially, the obsession with models and model accuracy and tuning models and hyperparameters. And the truth is this is really diverting data scientists from some of the real problems out there. So a lot of this is within their control, which is why they spend a lot of time on this and a lot of focus on this. But it's actually a very bizarre measure of success, model accuracy. And again, the truth is that some of the technology is actually not only keeping up, but staying ahead of people again. So AutoML is constantly improving. Don't get me wrong, I don't think any data scientist's job is in danger because of AutoML anytime soon, because there's obviously a huge amount of domain knowledge that still comes into play. But actually it's making life a hell of a lot easier for people. So this is some results from Google showing their performance of their AutoML tables products versus other vendors based on Kaggle leaderboard. So actually AutoML can do a pretty job, and in most cases it's better to come out with 10 very good models than spend your time producing one perfect one. And then it's always actually been recognized by a lot of people that machine learning code itself is actually a very small part of the solution if you want to create value from machine learning. So this is a famous diagram from Google's paper called The Hidden Technical Debt to Machine Learning. And that little black box that you can see in the middle, that's the ML code, but actually they say that there's a lot more that you really need to focus on: configuration, serving infrastructure, monitoring, and so on. But actually even there, I think they miss out on a lot of things which are a requirement for success, things like, data quality, make sure your stakeholders are brought in, team organization, security, and so on. So the truth is there's a bit of a dirty dark secret out there, which is that no one really wants to talk about any of these problems, or very few people want to talk about them, and they want to talk about the sexy stuff, the technology and the algorithms. And then within organizations, there's another challenge, which is, if you think about as data people who understands what you do, hopefully you do, your team do, Hopefully your manager does, not always a given. And then there's everyone who doesn't understand what you do, which is basically the rest of the entire organization. This is quite a big challenge because it kind of leads to a lot of problems. So one of the first problems you have is that a lot of senior execs think that the way you become data driven is that you hoard data, that you just hire some data scientists, some magic shit happens, and some money flows as a result. It's true that money flows, but it actually flows in the opposite direction because data scientists aren't cheap. Well, at least I hope you're not cheap, and the technology isn't cheap. Then there's a lot of legacy thinking around what you should be doing with the data. So there's a phrase which I love to ban, which is actual insight. So your job is to deliver actual insight. But the thing is, what use is actual insight if it doesn't get actioned? So, Gartner is predicting that through 2022, only 20% of analytical insights will actually deliver business outcomes. And this is kind of old-fashioned thinking because, until relatively recently, actual insight is all you could do. If you're a data person, you produced some recommendations after analyzing some data, made that recommendation to a stakeholder. They may have actioned it, may not. But actually the world's changed since then. So the first thing to do is actually to try and get alignment with the rest of the organization. So typically the way people think about planning is they think about resources. So how many people have we got? What's our budget? What's our technology? And so on. What activities are we going to do? What projects? What outputs are we going to create? But actually, there's more to it. There's something called the program logic model, which takes this further and says, well, actually, those outputs produce outcomes, and those outcomes have an impact. So we want to focus in on what impact do we want to have, what outcomes do we want to drive, and then flip everything on its head and say, okay, so in order to create those outcomes, what outputs do we need? What do we need to produce? And therefore, what resources do we need to produce those activities? So a few analogies. So we need a completely different approach to delivering outcomes from data than a lot of organizations currently have. So this is Thomas Edison's first electricity generator, and he installed it in Lower Manhattan in the 1880s. Very pleased with himself there. But then for the next 30, 40 years, absolutely nothing happened. Factories continue to run on steam, and no one wanted to rip out their architecture and replace all their steam engines and pulleys with new electric motors. And it wasn't until the 20s that people started really taking advantage of electricity, and we ended the steam age. So we're currently at that pivot point in history with data. So we're leaving the steam age behind, and we're entering the electricity age. So here's another analogy for you. Some of you, maybe only me, remember these phones. There used to be only one phone in the house, and actually it wasn't very portable. You had to go to the phone. And actually, telcos were one of the first users of computing. But in those days, computing was really expensive. So you couldn't really waste any time or resource. So there was a lot of rigorous upfront architecture development, a lot of requirements gathering, a lot of testing, before we even got anywhere near delivering an output. Someone hooked up a printer, and then BI and some reporting was born. But ultimately, once the data had been processed, so let's imagine you're producing a bill, and that's why you're using the computer. Actually, that data doesn't really have much value anymore. So that data was stuck on magnetic tapes and it was archives. And data wasn't an asset at all. It was actually a cost because the disk costs money, and the storage costs money. A little while later, people realized, well, actually, maybe there's some interesting value in this data. So data warehouses were born, but they still carried over from that original thinking around big upfront requirements gathering, long development cycles. I used to work in organizations where, if you wanted a new attribute delivered in the data warehouse, you could easily have to wait 4 or 5 years. And that's really not something that's viable today. So we need to move out of that steam age, and let's look at a modern telco today. So they will be getting data from many sources. So from set-top boxes, from the calls their customers make, from their website, from their CRM systems, from inventory, from their own stores if they have physical stores, social media, and so on. And they get that data in lots and lots of different formats. Some of it might be nicely structured, some of it will be unstructured, some of it semi-structured, and it ends up in lots of different data silos, which isn't necessarily helpful. And then thankfully, storage and compute are cheap though, so that's not too much of a big deal these days. But what you want to do is you need to be able to stitch all that data together so you can do some analytics on it. So there's lots of use cases for analytics, everything from customer lifetime value modeling, financial forecasting, pricing, strategy, segmentation, and so on. And then data becomes a really critical asset now because those analytical outputs can drive business use cases. So what should your tariffs be? Where should your network towers be located? Where should you spend your marketing money, and so on? So you need a brand new sort of process for treating data as this asset and taking it from the raw data from all these different multiple sources of data to delivering business outcomes. So you can't treat data as just some kind of application byproduct anymore. Data is a product in itself. So number two is you have to switch from project thinking through to product thinking. So this is DJ Patel's definition of data products. I think he was the one that coined the term data scientist, actually. So data product is anything that facilitates an end goal through the use of data. So it's what you should be aiming for. And a data product could be many things. It could be something as basic as a report. It could be a machine learning model or a monetizable data product. So if data is a product, then data analytics actually becomes complex manufacturing. In fact, it's extremely complex manufacturing. So in order to deliver data products, you need data storage databases, needs compute infrastructure, you need to be able to query that data, you need development workspaces, software, you need to be able to reproduce your environment, you need to be orchestrate data pipelines, you need to monitor those pipelines, you need data management capability, you need data analytics capability in terms of being able to explore that data, visualize it, produce machine learning models, and also to process and integrate that data, so ETL, data preparation, master data management, and so on. And then that creates your production system, so you can take raw data through to data products, which fulfill your use cases. But actually, there's another cycle or loop in there, which is the product development cycle. So what distinguishes projects from products is that products are long-lasting and they're iterated over time to improve and optimize them. So while at the same time you're got something in production, you also need to be improving that production process and that product. So in order to kind of deal with this complexity, we can borrow from other domains. So there are other domains out there that also have similar levels of complexity, that also have this production product development cycle. So kind of two that are most relevant are manufacturing. So lean thinking, which comes from Toyota's manufacturing system or production system. And then from software development, Agile and DevOps. The intersection of those with data analytics is DataOps. So the first place to start is applying lean thinking. So lean thinking is a system, Toyota calls it a system for the absolute elimination of waste. And one of the ways, there are many ways you can eliminate waste, but one of them is improving quality. The other is taking out any sort of delays. And one of the ironies is that data people will use data to tell other people what they want, what they should be doing, but very rarely use data to be introspective and understand how well they're performing and what they could be doing better. So I remember at one of the first offsites that I ran when I took over the team, I asked people, well, how many of you tell other people in the organization what to do using data? Everyone's hand went up. And then I said, how many people actually use data to improve the way that you work? And no one's hand went up. So one of the first places you can actually start if you want to use data is look at your own processes. So one of the things we do is lean process mapping. So if you're not familiar with it, it's very simple, but very inlining. So you just draw a timeline left to right, and then you plot out your activities. So in this case, this is the timeline for development of a new machine learning model. And then what you do is for each of those activities, you plot how much time it takes. Anything which is value adding goes above the line. Anything which is non-value adding, like waiting or dealing with defects and incidents, goes below the line. And then what you can work out is your efficiency. In this case, this process is only 20% efficient. And then you can try and understand where you're losing efficiency and where you could actually tackle some of the major bottlenecks, which would actually enable you to actually deliver much faster. And we've done this with great success. So, historically, it used to take us a long time to make data available for analytics. So making a new data item available could be an attribute, could be an event data type. Could take up to 2.3 years a few years ago. But by working through the process and all the bottlenecks and streamlining, got that down to 3 weeks, could go down some more, but there's always some work involved in sort of development, testing and documentation and so on, which means that you're never going to get it down to 0 or even 1 day. So then once you have your production process up and running, there's a development side of it, but there's also orchestration. So how do you orchestrate production pipelines to make sure that they continue to run the way you expect them to? And this is, again, much harder than it was many, many years ago, because you have many, many different data sources now, lots of different data formats. There's lots of different tools you could do to orchestrate those data pipelines as well. You may have traditional ETL tools like us, like Talend. You may also use Apache Airflow as well. dbt is very popular and so on. And then you'll have multiple data products. So there's a lot more complexity in the technology and the number of pipelines, but then there's also an extra challenge with data. So the extra challenge comes with the fact that if you're doing software development, take the code for a calculator, for example, you could unit test your code. If you get 2 + 2 = 4, it's passed this test, and it'll always come out with the right answer 100 years from now. Problem with data is that there's a lot more complexity in the data itself than there is in the code. So your code for orchestrating data pipeline might literally just be a few lines of YAML or Python. But there's a huge amount of complexity in the data. You could have duplicate data, you could have missing data, late arriving data, someone could change a schema, someone could change the format of a field. There's just literally a massive long list of things that could break your data pipeline. And we often have issues on a kind of regular basis. So one of the things that you really must do is make sure that you have lots of monitoring and testing in place. So everything from file validation, data completeness, integration testing, end-to-end user testing, and every time you find a problem, add monitoring and add testing. We actually have an operational excellence team who actually work on this pretty much full time, and they're always trying to automate our monitoring and our incident reporting, and doing a lot of really great work at using data on those incidents to understand, right, okay, what are the major causes of issues and what can we do to tackle them. And then there's something else that you need to take into account, which is you really need rules and constraints. And this is sometimes quite hard for particularly data scientists to want to accept, that there are rules and constraints that you have to obey. But one of the things that you must really respect is that if you want to be able to move quickly, you need to have trust both in the data and people. So a lot of my time is actually spent on building trust in people and data. So working with stakeholders in the rest of the organization, InfoSec, with risk to say, look, we have the right processes in place, everything from role-based access control through to the right encryption, that we have proper metadata management in there, that we are scanning for personal data to make sure it's not where it shouldn't be, in order for us to be able to do our job more effectively. So this is an investment that you have to make. And a lot of people see it as a trade-off, like you have all this governance in there, it's going to slow us down. But actually, no, it's the opposite. If you have the right governance, it speeds you up. So then you have to deliver. So, all products and even projects have a life cycle which you need to manage. So there's conception, where you do the ideation, you come up with your ideas. You then move to development. There's some iterative development. If you're successful in your testing, then you move into production, you monitor in production, and then eventually there's a retirement phase. Now, a lot of products could be in production for many, many years before they reach retirement. So one of the ways of managing that delivery, one of the most common ways is to use an Agile framework. So Agile is all about having adaptability to change at its heart. Now, the thing is, there are actually lots of Agile frameworks. Sometimes people make Agile and Scrum synonymous. They're not actually. Scrum predates the Agile Manifesto. It was actually around for a lot longer. So the thing is, use what you think is best for your problems and your organization. Is not a one-size-fits-all. Not everything has to be a 2-week sprint. So we actually very rarely use Scrum. The reason being that within data, it's very hard to actually predict how long something is going to take. So with software development, you can have a pretty decent stab at estimation of how long it might take to produce a feature. But with data, until you actually start drilling into the data, you're often not sure what you're going to find. And often there's a lot of iterative experimental loops. So we typically tend to use Kanban more, or at least Scrumban, which is a mix of some of the practice of Scrum with Kanban. But actually there are a lot more frameworks. So find one that fits you and your problems and your organization and your people. There are actually much larger frameworks as well. So if you want to scale up, so beyond team. So another drawback of Scrum is that you need relatively large self-contained teams. You can actually then start to bring in some of the practices from things like scaled Agile or disciplined Agile and so on. But the most important thing is to stay true to those Agile Manifesto values and principles: people over processes, working prototypes, responding to change, customer collaboration. So there's a lot of fake Agile out there where people pretend they're being Agile because they're picking on one or two practices, like having a meeting standing up every morning. But that kind of entirely misses the point. It's really about making sure that you're true to the values and principles. So then Agile would actually be nothing if you weren't able to make changes to your data products on a frequent basis. So the reason you want to make frequent changes is that it reduces risk for a start. So, big changes are more risky than small changes. You also get more feedback. So if you're making small changes, you can learn earlier. So in order to do that, DevOps was developed within software development, and it came about because of this conflict between developers and operational teams. So developers wanted to make lots of change, and operational teams wanted to minimize change because they didn't want to be waking up at 3 o'clock in the morning to have to reboot servers or recover failed jobs. So DevOps aims to bridge that gap by allowing teams to make small, frequent changes, and it does that in a few different ways. So firstly, automated reproducibility is at the core. You need to know that your production environment, your test environment, and your development environments are the same, so that when you're developing and testing, you know that something that has passed your test in the test environment will run it in exactly that same way in the production environment, not break because, say, you're missing a package. So version control is pretty critical to this. I'm sure you mostly are familiar with, Git and GitHub and so on. We use Bitbucket. So version control allows many good things, actually. So it allows you to return to a good known version of code should something go wrong. It allows for things like peer review. It allows you to reproduce the same code across different environments. But it's not only the code that needs to be reduced, it's entire environments. So, historically we would use, virtual machines, less popular these days. We're mostly using Docker containers. There's also package managers, so pretty popular within data sciences, Conda and Anaconda. But there's also configuration orchestration, which is not just the software, but also the entire environment that software runs in. So we used Terraform for that, but if you're on AWS, you might be using something like CloudFormation. So once you have that, then you can move to much more automation of your development through to delivery in your production environment. So you can start with continuous integration, which is you commit your code, that triggers unit tests. Then you can run integration tests in the test environment. Then you can look at the results on that and then manually QA and accept those results in the UAT environment before deploying to production. And then you can move a step beyond that and even automate that last step. But we're not there yet. So it has major advantages going down this route of DevOps and reproducibility. So, one of the things you can do is you can split up pipelines. So, machine learning pipeline is split up into many separate jobs, which run in separate Docker containers, and these jobs can be parallelized. And then it becomes much easier to make changes in tests. So, historically, it takes us a very long time to make changes to machine learning pipelines and run those changes through. Now we get those down to literally minutes as a result. So if you're making lots of changes in the code, there's something else to watch out for. So what you want to do is you want to make sure that any changes you're seeing as a result of changing code are due to the code and nothing else. So this is where test data management becomes super important. It's really important that you keep your test data constant, and so that when you're testing and making changes to your code, you're only changing one thing at a time. So what you ideally want is a copy of your production data, or at least a very large sample of your production data, so that's reflective of the kind of data that you would see in a live production environment. In your test environment, sometimes that's not always possible. Sometimes we have to rely on sort of synthetic data, or recreate the state of data based on historic event data that we have. But it's really critical that you kind of have a strategy around this, and so it's going to be another sort of area of focus for us, where we're going to look to see what further improvements we can make in future. And then on to people. So number 9 is, so we talked a lot about the sort of process. Now we're on to people. So some of you may have heard of Conway's law, which kind of says that organizations which kind of design systems are sort of constrained to produce designs which are reflective of their internal organizational structure. So that's kind of a complicated way of saying that your customer experience quite often reflects how a company is internally organized. And I can often see this with, the experience you get on a company's app is very different to their website, which is very different to the experience you get in store. And that's because there are very different teams internally running them. And that's not just academic. So again, this is some famous research by Microsoft. They went back and they looked at Microsoft Vista and tried to look for why did some piece of the code turn out to be more reliable and higher quality than other pieces of the code. And they looked at lots of different factors, like was it the complexity of the code, was it test coverage, but actually they found that the biggest predictor was actually the organizational structure. So the way the team structured actually massively influenced the quality of the code they produced. And that's important for data teams because historically data teams have been functionally organized. So you would have a team of data scientists, team of BI developers, team of data engineers. Now this way of organizing teams is designed to maximize resource utilization. So it's basically make sure that everyone is really busy, because as soon as anyone becomes free, they're assigned to a project, and also make sure there's no duplication. For example, you wouldn't necessarily want an architect in every single team. Most of the time they'd just be sitting there twiddling their thumbs. So what you want is to be able to just hire enough people, make sure that everyone's really busy. Although it has some advantages, like, everyone works with teams with the same skills, so you have consistency of knowledge and consistency of hiring, it actually has massive downside. So although it's optimized for resource utilization, it's not optimized for teams. And hopefully a lot of you can relate to this diagram, whereby, just coordinating teams and making sure that people are available at the right time to work on the right things is really, really hard. Work often ends up in another team's backlog because they're not ready, or they're waiting for another team to produce their work. Then you get into all these fights over prioritization. My work's more important than your work. Can you push it through? And everything just gets bogged down, especially if teams don't share objectives. So a big finding from another famous bit of research by McKinsey, they looked at why certain organizations were better at using data and creating value from data than others. And they came up with lots of clear differentiators. And number 6 was that the high-performing teams, they actually had cross-functional, collaborative, agile teams, well, at least a lot more likely. So of those breakaway organizations, as they call them, 60% of them use cross-functional teams. Compared to a third of all the rest of the organizations, which was pretty much the majority. So we've kind of gone down this route of trying to create cross-functional teams. So one of the things that we kind of have is sort of core personas. So, we have data scientists, we have sort of product analysts, data engineers, and so on. And the thing is, you can't get everyone into a cross-functional team. There will always be people who have to sit outside that. So, some data architects sit outside that, and so on. So it's not quite possible to have 100% cross-functional teams. But if you look at your core personas, you can identify those individuals. And I call them personas because every organization has slightly different sort of job titles. You can have a look at those core personas and say, well, actually, how many of those could actually be grouped together into a cross-functional team? But we did find that there is actually still a problem within cross-functional teams, which is you move the silo from between teams to within the teams themselves. So one of the things that you have to do is cross-skilled team members. So rather than have people working in parallel, so you might have like a data engineer in the team who needs to do his work before the data scientist can, before your QA can do their work, is to cross-skill people so that actually they can do a little bit of each other's role, and that removes some of the bottlenecks in the team. So rather than be stuck waiting for someone else in the team to help out, actually you can keep the flow going and actually work on parallel. So what you have to do is move away from the traditional way of looking at team members. So historically, team members would have been I-shaped, specialists, so deep expertise in one thing only, and typically led by generalists, so dash-shaped people who might not necessarily have a lot of deep knowledge in any one thing, but they've got quite broad knowledge and maybe soft skills and project management skills and stakeholder management skills and so on. A move to make people, in agile terminology, generalizing specialists or T-shaped. So they still have that deep knowledge, but they have some knowledge of being able to work in other domains. And then taking that further into making people pie-shaped, so developing a bit of depth in other areas. Find this is kind of easier with like data engineers and product analysts who want to understand a lot more about data science. A little bit harder the other way. It's quite difficult sometimes to encourage data scientists to learn about data engineering or product analytics. And eventually the kind of the holy grail is to make people poly-shaped. And my computer froze. Right, so kind of what we end up with is domain-orientated cross-functional teams. So domain for us might be our brands, travel supermarket, money saving expert, or our product verticals, or customer, so marketing, personalization. But it's important these teams do not become isolated, because you still want consistency of best practice of hiring and so on. So they must be tied together through leadership and center of excellence. And then we have like a data management platform team, and their job really in simplistic terms is to make sure that the other teams have the right data and the right tools in order to be able to do their jobs, and to have essentially as much sort of self-service and the ability to productionize their work as possible. So then moving on, so it's really important while you're doing all this to make sure that you're also measuring and acting on the feedback. So remember, we're trying to drive outcomes. So there are a few dimensions by which you need to do this. So one is by viewpoint. So you've got your own internal viewpoint. So for instance, you might be running retros on how well your team is performing. You might be doing monitoring as well. So how are our data products functioning? But actually there's also the viewpoint of your customers, your stakeholders. So it's really important to get feedback from them. How are you doing? Are you meeting their expectations? Are you delivering? So, we make sure we're very much aligned on objectives. So we share a lot of common OKRs with our stakeholders. And we also need to make sure that what we're delivering is fit for purpose as well. So is how we're doing the work that we're doing fit for purpose? What do our stakeholders think of us? So it's really important to take that customer versus team viewpoint, and also service versus the actual data product viewpoint. So finally, I'm just going to move on to technology. So just as, DevOps is far more than technology, DataOps is more than tools, and hopefully you saw up front that actually technology is not quite as important as people often think it is. So kind of left it to last. One of the things is with DataOps is that, there are DataOps tools out there that help you do DataOps, but actually long gone are the days where you just went to the likes of SAS or Oracle and IBM and said, we've got data, sell us a solution that will allow us to do data analytics. These days, you need to basically pick a whole range of technologies, pick the best of breed, and be able to combine them. Obviously, Domino is a big part of that for us at Moneysupermarket. We combine Domino with Google Cloud Platform and many other technologies we use. Now, it can be a bit overwhelming trying to deal with just the sheer number of solutions out there and the amount of change. So one of the things that we do is we have a tech radar. So we borrowed this from ThoughtWorks and consultancy. And what we do is we look at the range of technology out there. And every 6 months or so, data architects and some of the leadership, we sit together and we say, look, is there anything that we know about out there that we should be considering, trialing, running a POC on, or even discounting? Because to be honest, there's just so much technology out there that, you can't possibly evaluate it all. So quite often it's useful just to be able to say, look, that piece of technology, probably not relevant, let's park it. So just coming up to the end, I've kind of gone through a lot of content there. Hopefully you've got something out of it. There's only so much I can basically share in 45 minutes. If you want to find out more, I have actually written a book which goes into a lot more detail. You can find it on all your favorite Amazon websites. That's it for me. I am happy to take questions now.
Thank you, Harvinder. It was a great presentation. Question, you had mentioned earlier in your presentation around using AutoML tools to complement your expert data science stack. Curious if there are specific tools that you use and how like the AutoML tools are integrated with the more expert-oriented data science tools and platforms.
So we did use, we are evaluating AutoML, which is part of Google Cloud Platform itself. It's a Google offering, and we did use oh god, name's completely gone. So we did use. It'll come to me in a second. Don't worry. We did use an AutoML product a few years ago, and to be honest, we found that for our problems, it was kind of coming out with the same solution every time, which was to use XGBoost, and we found, well, actually we could relatively easily create our own XGBoost modeling pipeline, and kind of create those models in a relatively semi-automated way. The bit that then we have to kind of create in-house is the serving side of it. So there's two sides. Obviously, there's the training the model, you create a model artifact, but then you have to serve that model, whether that's batch or via an API in real time. So that bit took takes more manual effort. That we kind of do in-house, and there's various ways that you can serve model. You can have batch processes. You can build the model into your application itself. You can serve our APIs, and we use all kind of three approaches depending on the actual scenario. So yeah, I mean, I think AutoML is great where you just want to create a very quick model, especially when you're trying to just understand the value of deploying the model to solve a problem in the first place. So you think the model is just one part of a solution. So it might be, let's say, a recommendation engine, or it might be churn prediction, might be fraud forecasting, or whatever. So if you've got a new problem and you're not sure, the model may be predicted, but you're not quite sure whether the value will be created from deploying the model in the real world, it's a very quick way of just being able to test that out. But yeah, there are definitely cases where using your domain knowledge and being able to go put extra effort into tuning the model and going for a higher level of accuracy is definitely advantageous. So, there are domains like ad tech, healthcare, fraud detection, where you probably want to put a lot more effort, manual effort into the process and not rely so much on AutoML. And a lot of AutoML solutions actually don't deal with the feature data set creation anyway, which is where you get a lot of the value from.
Interesting. Thank you. And you talked a lot about lean process mapping. Do you have examples of business use cases where you've actually improved efficiencies by using that process?
Yes, several actually. So one is the sort of end-to-end ingestion process for taking data that we capture as events. So we get events from our website, go through a Kafka pipeline, ends up in things like S3 buckets. Then from there, we have batch processes, which basically do ETL to our data warehouse. And we were able to kind of map out that process and look at, well, where can we actually, one, speed up that entire process itself? And so we've done a really great job of being able to automate a lot of that process, inspecting those event files to understand what the schema is of those event files, and throw up errors if there are any, and detect them early. But also within the entire development lifecycle, to say, look, where when we're integrating new data, do we have to spend a lot of time on development in order to essentially either bring it into our data warehouse or make that event data available to our data scientists, or bring it into Google Cloud BigQuery. And so by doing that mapping, we were able to discover that there was a lot of manual effort involved in trying to understand the schema of those files and changes in that schema. So spent a lot of time trying to automate that and automate the testing as well. We also done that with product development as well. So, when we've launched new products, we've done kind of retros, mapped out, why does it take us so long to build those new data pipelines for a new data product? Where are the bottlenecks? And then that throws up, it's mostly organizational things like, we need to work more closely with the front end developers to make sure that, our requirements are met, that we've got the right test data up front and things like that.
Interesting. You had showed a slide about the different cross-functional teams in your organizational structure. And then you did show sort of a center of excellence off to the left-hand side there. How does that center of excellence interact with the functional teams? And like, what is the organizational reporting structure between the center of excellence and those teams?
Yeah, so it's a mixture of hard reporting lines and sort of virtual dotted lines at the moment. So, over time we'll evolve it. So some of it is, the data scientists will be reporting into my head of data science. So that is what brings those teams together in terms of data science expertise. But some of it will be a little bit more virtual, where people who want to share knowledge or are working on similar things will come together to share best practice and training and learn from each other.
Excellent. And on the topic, going back to the AutoML topic, have you considered H2O, or can you share experience on how you've chosen data science and or AutoML platforms?
Yeah, so we haven't looked at H2O, but typically what we do is one of the things when we're looking at new technology is we're very clear on what functionality we want. So what features do we need, and we create a sort of rating or ranking. But against that, we have some real life use cases. So something that we're actually doing or have done that we can use as our use case test cases for running a POC. And typically what we'll do is we'll kind of like have a funnel, we'll explore the entire kind of solution space, chat to lots of vendors, and then kind of use our criteria for what we need versus, speaking to the rest of the market to narrow that funnel down to people we want to actually run a POC with. And most vendors are pretty happy to help out in that space. And then we would use some actual data, some actual use cases where we have internal ground truth around, how good are we at, creating models and the accuracy of those models versus the automated solution. And then we will then score and rank, is there time saving, is there accuracy benefit, versus the cost involved, opportunity cost, and so on.
Great. Over time, DevOps has expanded to become DevSecOps. Do you see a need in the future to expand DataOps to be DataSecOps to handle data security?
Yeah, that's actually already a thing. So Data Kitchen, who are kind of vendor in the and thought leaders in the DataOps space, are going to be running a talk soon on DataSecOps. So yeah, no, definitely a thing. Data security and data privacy are really important for us. So we handle a lot of personal data, and we take it really seriously. So it's about making sure that we can handle data securely, but while still being able to be very agile and work at velocity. So you can only really do that if you build some of the security into your development. So one of the things, for instance, we do is, when we're bringing in data and we want to then take it from, effectively the landing zones in S3 through ETL processes to a place where the data scientists need to use it. Well, data scientists don't need that personal data. So, we'll build in things like, whitelisting. So, only certain attributes are allowed through, the rest must be typically use hashing. So that process is automated. We do a lot of scanning, as I mentioned before, for personal data. So, we scan our systems to make sure that personal data doesn't end up in places it shouldn't. And again, it's about building that into your workflows and into your automation.
Are you thinking about, or have you integrated a security expert into the core teams?
So we have group InfoSec. So we have an information security function within our tech function. We kind of like work to their guidelines. So internally we use something called CIS, which is a security standards, computer information security. I can't remember what the acronym stands for, but other people use ISO 27001. So we have these standards that we work to, and then we get our InfoSec team to rubber stamp what we've done.
Very cool. How has this might be our last question, but how has your team dealt with solving data drift problems and addressing that through DataOps practices?
So data drift, is that the same as concept drift or model drift?
Yeah, I think so.
Yeah, so all models will eventually decay in predictive power over time. Markets evolve, consumer behavior evolves, data changes, and so on. So we are historically, it's been a very manual process of having to have a look at the performance of those models and seeing whether we're still getting uplift. So typically, what you want to do is basically always kind of have some kind of fallow group or control that you're measuring uplift of what you're doing against, so that you can measure that change in lift that you're getting over time. But it's been a very sort of manual process and sort of ad hoc rebuilding of models. But yeah, we're actually at the moment at the stage where we're revisiting all our model pipelines and model training. And one of the things we're building in is the ability to set thresholds and auto train models when they fall below a certain threshold and retrain, because we're quite conscious that doing it in a very manual way is not the best way.
Okay, well, I think that's about all we have time for today. Thank you again so much, Harvinder. It was a great presentation. And thanks for everyone who attended today. We will follow up in the next few days with the recording of the session in case you want to watch it again or share it with your colleagues. Thanks, Harvinder.
All right, thank you, everyone. I hope you find it helpful.